V was 100, division of 36. I was 10.77, angle of 111.8 degrees, if I'm not wrong. Yeah. So Z will be division of V by I, which makes it equal to 100 by 10.77 for the magnitude scale, and for the angle it will be 36.9 minus 111.8 degrees on the angle scenario. So that makes it 9.28, 9.28, the angle of minus 74.9 degrees, minus 74.9 degrees. So what does this mean? This is the, sorry, this is in ohms. So Z is equal to this. What does this mean? Let us come to that. This means that if you convert it to, this is the polar form. If you convert it to the rectangular form, then Z will come to around, just have to simply do one thing, that is 9.28 cos of whatever the angle is there, that is minus 74.9 degrees, and then minus j sine of minus 74.9 degrees. This should come to, for the real part, this should come to 2.42, 2.42 minus j into 8.96 ohms, which means that the real component, or R, the resistive component, is this one, and since this is minus j, that means xc, or the capacitive component, is this much. Okay, so this is a very interesting solution that you have got here. From the Z, if you convert it into the rectangular domain, you have already found out, since this is minus, it will be xc. If it were plus, then it would have been xl, that means inductive reactance. So this is the value of inductance. So the first part, the impedance of the circuit, it is obtained. Now let us go to the power consumed. So power, we know, can be given by three things. For this we will consider I square R, because we know that xc will not consume any real power. The real power is consumed only by the R. So I was how much? Minus 4 plus j 10, right? Which made its magnitude to be 10.77 amperes. We will not consider the angle, because the phase angle has nothing to do with the magnitude, and we know that power is a scalar quantity. It depends only on the magnitudes of the components. So 10.77 square into the value of the resistance, that is 2.42, and that should come to around 280.9 703 watts. Guys, please remember to write the unit after the result, otherwise it makes no sense. So as per the problem, the power consumed has been found out, and finally we'll go for the phase angle. So phase angle theta, it can be found out in a very simple way. So it's basically nothing but the difference in the angle between V and I. So since we have already found out the polar forms of V and I, we know that V is at an angle of 36.9 degree, whereas I is at an angle of 111.8 degrees. So if you uh, subtract them, then we have already found out how much it was. It was minus 74.9. Can you see? We had already subtracted that. So minus 74.9 degrees, which means that in a coordinate system, 36.9 minus 111.8, which gives 74.9 degrees minus, that means theta is equal to 74.9 degrees leading. So we have already established that the impedance consists of XC, that means capacitive load. When it's capacitive inductance, then that we know that the current will be leading the voltage. So this is your final answer. The current will be leading the voltage by 74.9 degrees. If you have to draw a phasor diagram, it will be like this. This will be V, and if this is the perpendicular, you can imagine the final current will be somewhat, pardon my drawing please, somewhat like this. This will be the current. This angle will be 74.9 degrees in a leading capacity. Understood? This was one of the very conceptual problems that we addressed in this video. See you in the next video with another problem. Bye bye.